Welcome to the Explainer. So, if you work anywhere in IT support, DevOps, or site reliability engineering, you absolutely know that sinking feeling of a high-stakes application outage. Modern web development is incredible, right? We're using these super robust frameworks like React, Next.js, and TypeScript to build lightning-fast user experiences. But to make those heavy, complex apps actually run quickly over a network, the code has to go through this massive transformation. It gets transpiled, tree-shaken to get rid of dead code, bundled up tightly, and then minified to strip out spaces and long variable names before finally being chopped into optimized chunks. Now, that's fantastic for network performance, but when a critical error happens in production, well, that heavy optimization leaves us staring at an absolute nightmare of unreadable gibberish. So, today, we are going to fix that process from the ground up.
Okay, put yourself directly into this scenario. It's 2 a.m. Your PagerDuty alert suddenly goes off, waking you out of a dead sleep. A critical JavaScript error is taking down the checkout flow in your production environment. As the support engineer on call, you are the first responder. Customer complaints are already piling up in Zendesk, and your Slack channels are literally lighting up with frantic messages from the engineering director. So you rush to your monitoring dashboard, pull up the alert, and pray for a clear, actionable error message. But instead, you get a stack trace pointing to something entirely cryptic called chunk12345.js, failing with type error e.map is not a function. You have absolutely no idea what React component is actually failing, what specific file it lives in, or even which engineering squad to escalate this to. You are completely flying blind in the middle of a massive outage while the business is losing money by the minute.
Let's really think about what we're actually up against when we look at these errors. A minified stack trace gives you something functionally useless, like bundle.min.js, line 1, column 84,321. Because all the code was squished onto a single line to save space, the line number is basically always 1, and the column number is massive. It's just a giant wall of dense text. What you actually need for effective triage is clarity. You need something like app.tsx, line 42, inside the user auth component, right? That is the exact original source code that the front-end developer actually wrote in their code editor. We desperately need a systematic way to magically translate that chaotic minified mess back into that actionable, precise perfection so we can quickly figure out what broke.
I love this brutally honest quote because it highlights exactly why this matters to the entire organization. This is what your developers see without source maps. When you, as a support or ops engineer, escalate a purely minified error to the engineering team, you're essentially handing them a 1,000-piece jigsaw puzzle without providing the picture on the front of the box. It absolutely destroys your MTTR, your mean time to resolution. It creates these massive triage bottlenecks because developers are forced to waste hours reverse engineering their own minified code, trying to guess where the bug lives based on single-letter variable names. It's a terrible use of expensive engineering resources, and it needlessly prolongs your production downtime.
Section 2. The treasure map. What is a source map?
To understand how we bridge this massive gap, we really need to define our core tooling. If heavily minified front-end code is like buried treasure, or, well, in our high-stakes case, a buried production bug, without any geographic coordinates, the source map is literally the X that marks the exact spot. It's a specialized, automatically generated JSON file that acts as a translation layer. Using a specification called base64 variable length quantity encoding, this JSON file painstakingly maps the bundled minified production code back to the original source files. It retains the original variable names, the original formatting, and the exact line and column numbers. It is literally the definitive Rosetta Stone for your JavaScript build.
Get this, it's not uncommon to see a staggering size difference here. A source map file might easily be 1.5 megabytes, while the actual compressed source code bundle it represents is only, say, 778 kilobytes. Source maps are massive, highly detailed JSON structures. And because they're so incredibly large, serving them directly in a production browser environment is a terrible idea. It would drastically slow down the application for your users, which entirely defeats the purpose of minifying the code in the first place. Even worse, it could potentially leak your proprietary business logic and unreleased features to anyone who just opens their browser developer tools. That is exactly why we never serve them publicly to the browser. Instead, we securely upload them to a dedicated observability platform, like Sentry.
Moving right along to the execution phase, uploading with the Sentry CLI.
Executing this strategy requires a brisk, highly reliable 4-step technical pipeline. Think of this as living right inside your GitHub Actions or Jenkins CI/CD workflow. Step 1,
Your build tool, whether that's Vite, Webpack, or Next.js, compiles the React project for production, which actively generates both the minified JavaScript files and their corresponding .js, .map source map files. Step 2, we inject special unique identifiers called debug IDs into both the compiled files and the maps. Step 3, we leverage the Sentry command line interface as a post-build step in our runner to securely upload those artifacts directly to Sentry's backend servers. And finally, Step 4, we deploy the application. Crucially, your deployment script copies only the JavaScript files to your public CDN or S3 bucket, explicitly deleting or ignoring the source maps, so they remain strictly internal.
Now, the true linchpin of this entire operation is the concept of the debug ID. Historically, Sentry and other tools tried to match source maps to errors by looking at file paths, URL structures, and release versions. And honestly, this was notoriously fragile. If a cache-busting hash in your file name changed or a CDN altered the URL path, the source map connection broke instantly. Sentry fundamentally solved this by introducing debug IDs. Think of your minified JavaScript file as a physical, complex widget, and the source map as its detailed instruction manual. Injecting a debug ID is like stamping an identical, globally unique model number onto both the widget and the manual. Now, Sentry doesn't have to guess based on dynamic folder paths, it just reads the ID embedded in the crash report and matches it directly to the exact ID in the uploaded source map repository. It is 100% deterministic and highly reliable.
To actually make this pipeline a reality, we utilize these two exact terminal commands from the Sentry CLI during our build process. First, Sentry CLI source maps inject, followed by your target build directory like .dist. This command scans your freshly built files locally within the CI runner and stamps them with those unique debug IDs. Immediately after that, Sentry CLI source maps upload .dist pushes those uniquely stamped files securely up to Sentry over the network. Now, for this automated pipeline to succeed without human intervention, you absolutely must have an active Sentry auth token environment variable configured. In a real-world setup, you'd store this token securely in GitHub Secrets or AWS Secrets Manager, exposing it only to the CI runner when these commands execute. It handles all the heavy lifting automatically.
Which brings us to the validation, the before and after.
Let's return to that terrifying 2 a.m. scenario and see the difference. Without source maps properly uploaded to your observability platform, you're hopelessly stuck staring at a random chunk error like static/chunks/12345-something.js. But because our CI/CD pipeline successfully and securely uploaded the source maps using those unique debug IDs, the entire experience changes. Sentry intercepts the incoming error from the user's browser, instantly reads the embedded debug ID in the background, pulls the correct source map from its internal vault, and dynamically unminifies the stack trace on the fly. Suddenly, your eyes are guided exactly where they need to be. app/page.tsx, line 42, pointing directly to a specific function inside the exact React component that triggered the crash.
And finally, the resolution, the perfect bug report. When you have source maps working flawlessly in your pipeline, you fundamentally transform your role. You stop being a mere escalation bottleneck, and you become a highly effective triage hero. Because now, you have the power to write the absolute perfect bug report. Imagine opening a Jira ticket at 2:15 a.m. that is incredibly precise. You can confidently set the title, define the environment, and write, "The user auth component is failing precisely at line 42 due to a null reference on the user profile object." You are providing the exact component name, the specific line number, and the original error context. And you know the most powerful part of this new workflow? Zero developer ping-pong is required. You don't have to vaguely message a developer on Slack and ask, "Hey, I think something is broken with login. Can you look into it?" No way. You hand them a fully diagnosed ticket containing exactly what they need to fix the code immediately, allowing you to move right on to your next task.
So, I want to leave you with this final, provocative thought to consider for your own team's infrastructure. Are your bug reports actually pointing directly to the problem? Or are you just pointing your stressed-out developers toward an incredibly massive haystack? By systematically integrating the Sentry CLI, utilizing those deterministic debug IDs, and securely uploading your source maps during your automated build process, you bring total clarity to the chaos of modern web application errors. Take control of your triage process today, start unminifying your errors, and finally stop flying blind.